Welcome to Study Loop.
Let's use the graph of this function f to decide whether or not this integral from 0 to 2 is positive or negative. We'll use the graph to give a rough estimate for the area, or the integral. Then we'll actually evaluate the integral to find the exact value. So let's look at the graph of f. Here we have f graphed in red, and let's focus on x values between 0 and 2. We see that the function's below the x-axis here. So in this case, the integral should be negative. Also, we can give a rough estimate to the area. So let's just approximate it by taking this rectangle with side going from 0 all the way down to negative 0.25. And then the length will be from 0 all the way to 2. So in that case, we just have 2 times negative 0.25. So that's just negative 1/2. So we'll just say 0, 2, f of x dx. Approximately, we had negative 0.25, so let's write that as a fourth, times 2, which was the length. This is negative 1/2, so that's a rough estimate. Now let's go ahead and actually evaluate this thing to find the exact value. That's where we'll need the methods of this section. 0, 2. Now, let's look at that denominator. We see that we can factor this as x minus 3, x plus 1. You should always do that. If you have a quadratic, always check whether or not that factors. Let's ignore the integral for 1 minute. Let's just look at the integrand so that we can do our partial fraction decomposition. So this is of the form a over x minus 3, b over x plus 1. This is what the author would call case 1, distinct, non-repeated linear factors. Let's go ahead and multiply both sides of this equation by the denominator on the left. Then we get 1 equals a, x plus 1, plus b, x minus 3. And we can rewrite this right-hand side is by factoring out the x. And then we're left over with a minus 3b. So we see that there's no x on the left-hand side. So we must have that a plus b equals 0. The constant term on the left is 1. That must mean that the constant term on the right is 1. Let's go ahead and solve this 2-by-2 system. If we subtract, we get 4b equals negative 1. This means that b is negative 1/4. So that a is positive 1/4. Now we have our a and b. Let's go ahead and plug these into the partial fraction decomposition, and then we could integrate this from 0 to 2. And I'll go to the next page to start doing this. The first integral, 0, 2, then a was 1/4, x minus 3. Then for the next term, we had negative 1/4 for b, x plus 1, dx. Now, if this minus 3 and plus 1 are bothering you, you can feel free here to do a u sub. In any case, we should end up with 1/4. Then we have natural log x minus 3 for the first integral, 0 to 2. For the second integral, we have a minus 1/4 and then natural log again. Then now we just go ahead and simplify by plugging in our endpoints. So for the first integral, in parentheses here, if you plug in 2, then you have negative 1, but you take absolute value, you get positive 1. And for the second term, you plug in 0, you get absolute value of negative 3, which is 3. Now for the second term, plug in the 2 first, and then plug in 0. Now just use the fact that natural log of 1 is 0 to cross out those terms. And then we can go ahead and combine these. Get negative 2 over 4 ln 3, which is negative 1/2 ln 3. That's the exact answer, and it's a negative number.